Intro Algebra, Lesson 4-5b. Last time we introduced the concept of constant and direct variation and the fact that a constant and the slope are the same thing. Today we're going to take it a little bit further and see if we can find out what a constant is or possibly how to use that constant to determine some other values. So here's a couple examples. Our first example is, let's say that x and y vary directly. As soon as we read this, we know we're dealing with y equals kx, or y over x is equal to k. It tells us if x is equal to -3 and y is equal to -30. So that's a situation. Out of this information, y, k, and x, we're given the x and we're given a y, but what we don't know is the constant. We don't know that, but we can figure it out. It tells us right here, if you want to know the constant, take the y value and divide by the x. So we could do that, all right? Write an equation that relates x and y. Well, if we write an equation that relates x and y, we would say something like y equals kx, so -30 is equal to k times -3. But that's just a start. If you stop here, then you won't have fully written your equation that relates x and y. We need to find what k is. We don't want to have numbers in for y and x when we're writing our equation that relates them. We want to find out what k is, and we divide by -3 to get k alone. Those cancel out. -30 over -3 is 10, so 10 is equal to k. Now if you stop there, I still have to mark it wrong. You need to write an equation that relates the two. So here's the relationship. Y is equal to 10 times x. Think about what it says up here. Is -30 10 times -3? Yes, it is. So this equation connects the two. One of the biggest mistakes that I see is people write this down and then I have to mark it wrong. Then people write down this and I have to mark it wrong. And lastly, people like to write down this. -30 is equal to 10 times -3. And then I have to mark that wrong. What I am looking for is not any of those three versions, but that version right there. I want y to be y, I want x to be x, but I want the constant in there, because that constant is what's connecting the x and the y. Alright? So that's a pretty big one. A lot of people make mistakes with that. You've got to be very careful. Okay? Let's look at a second example. Again, it tells us x and y vary directly. What does that tell us? That y equals kx, or y over x is equal to k. They tell us that x is 8 and y is 48. But what they don't tell us is, they don't tell us the constant. So if you wanted to, you could say 48 over 8 is equal to constant. And 48 divided by 8, 6 times 8 is 48, which means the constant is equal to 6. Now that you know the constant is 6, writing the equation should be pretty easy. Y equals 6 times x. Is 48 the same as 6 times 8? Yes. So it connects the two. So very similar two problems. On this one, we had these two values that varied directly. So we used that to solve for k, and then we wrote our equation. On this second problem, we know these two values are varied directly, so we use the two values to come up with our constant. So here's our equation. Notice that y and x are y and x. We do not put the values 8 and 48 in our final answer. Alright? X and y vary directly. So once again, y equals k times x, or y over x, get better room, or y over x is equal to k. What we don't know is the constant, so we substitute the values in. -2.2 over 6.6 is equal to constant. One of the biggest mistakes is people take 6.6 and divide it by 2.2. It's actually -2.2 divided by 6.6. So one thing you could look at is that's like 22 over 66, which is going to equal -1/3. So writing the equation that relates the two, we'd say y equals -1/3 times x. Y equals -1/3 times x. So the first three problems that we just looked at were all basically the same. You have to find the constant first. Once you find the constant, you can then write your generic equation that relates the two. All right, let's look at one more. X and y vary directly. So y equals k times x, or y over x equals k. So we're looking at our values. It says that 3 1/4 is x and y is 8. So we could say 8 divided by 3 1/4. Now that's a little tricky. You're not going to be able to just do that so easily in your head. So maybe what you ought to do is change the 3 1/4 into an improper fraction. So now we have 8 being divided by not 3 1/4 but 13 over 4. And anytime you divide by a fraction, it's the same as multiplying by the reciprocal. So you could say that this becomes 8 over 1 times the reciprocal, 4 over 13. So instead of being 8 over 1 divided by 13/14, we flip it. And now fractions multiply straight across, so you get 32 over 13 is equal to k. Now when it comes to writing your equation, you would say y equals 32 over 13x. And that's your final answer. That is the equation that connects these two values. If you stick 3 1/4 right here, remember 3 1/4 is 13/4. If you put 13 over 4 in here, the 13s would cancel and you'd have 32 over 4. 32 divided by 4 is 8, so it does work. You can check to make sure it works. Now that we know that information for our equation, let's see if we can use our equation to find out what y would be if x was 8. Well, if x was 8, we'd have y equals 32 over 13 times 8 over 1, because that's what x is equal to, and we substitute it in. You multiply straight across, and you end up with 13 on the bottom, and 8 times 3 is 240, and 8 times 2 is 16. So you add 240 plus 16 is 256. Now, if you would like, you can leave it as an improper fraction, or you can try to simplify it down into a mixed number. All right? Either way is fine, but y is equal to 256 divided by 13. All right, one step further, use your equation to find y if x equals -5. So we use the same formula, but instead of 8 over 1, it's going to be -5 over 1. So y is equal to 32 over 13 times -5 over 1, which equals 13 on the bottom once again, except this time -5 times a positive is going to make a negative answer. And 5 times 30 is 150, 5 times 2 is 10. You end up with 160. Now if you'd like, you can leave it as an improper fraction, or you can try to simplify it down as well. It's up to you. But either way, you still have to take the equation we came up with, and then substitute values in for x, multiply straight across to come up with your values for the y. And that's how we use direct variation. First we must find our constant, then we can substitute values in for our equation and come up with the answer for y as it relates to the other according to that constant of variation.